Download this code from codegive.com, link in the description below. cntk 126/10 Kernel Debugging with windbg, a comprehensive tutorial. This tutorial delves into the process of kernel debugging specifically in the context of cntk, Cognitive Toolkit, version 126/10, using windbg. While cntk itself is more of a user mode framework, debugging it at the kernel level becomes crucial when dealing with driver issues, memory corruption scenarios that affect the OS, or low-level performance investigations. This tutorial assumes a foundational understanding of operating system concepts and debugging principles. Disclaimer: kernel debugging is a complex and potentially dangerous undertaking. Improper use can lead to system instability or even corruption. Proceed with caution and always back up your system before experimenting with kernel debugging. Prerequisites *. 1. 2 machines *. The ideal setup involves 2 machines. Target machine *. This is the machine running the cntk 126/10 application you want to debug. This is often referred to as the debugee. Host machine *. This is the machine where windbg will run and control the debugging session. This is often referred to as the debugger. 2 windbg *. Download and install windbg on the host machine. The latest version from the Microsoft Store, windbg Preview, is highly recommended, but the older windbg from the Windows SDK also works. 3 Windows symbol files *. Configure windbg to access the Microsoft symbol server. This allows windbg to resolve function names and variable addresses, significantly improving the debugging experience. You can set this up in windbg settings, file-settings-symbol file path, or using the .sympathy command. A common configuration is: replace /symbols with a location where you want to store the downloaded symbol files. 4 cntk 126/10 installation *. Ensure cntk 126/10 is installed on the target machine and that you have a reproducible scenario that triggers the kernel level issue you want to investigate. 5 Target machine configuration, networking or serial. Choose a connection method between the host and target machines. Networking, recommended. This is the most common and often the easiest method. It requires both machines to be on the same network. Serial. A serial cable connection is an alternative, but it's generally slower and requires specific hardware, serial ports. This tutorial focuses on networking. 6 BCD edit configuration on target machine *. This is the crucial step that enables kernel debugging on the target machine. 2. Target machine configuration, BCD edit. BCD edit is a command line tool used to modify the boot configuration data, BCD, store, which contains boot parameters for Windows. You need to enable kernel debugging and set the debugging connection parameters. 1. Open an elevated command prompt *. Run cmd as an administrator on the target machine. 2. Enable debugging *. Execute the following command. 3. Configure debugging connection, networking. Find network adapter *. Determine the network adapter on the target machine that you want to use for debugging. Run IP protocol configuration in the command prompt and note the name and IP address of the relevant network adapter. Set debug port and key *. Choose a port number, example 50,000, and a debug key, any string you like. The debug key acts as a password to prevent unauthorized debugging access. Execute the following command, replacing your _network_adapter_IP, 50,000, and your _debug_ key with your actual values. Example *. Make sure to use the IP address of the target machine's network adapter. For reboot * restart the target machine. Windows will load with kernel debugging enabled, but the debugger will not be connected until you start windbg on the host. 3. Host machine configuration, windbg. 1. Start windbg * launch windbg on the host machine. Run as administrator to avoid potential permission issues. 2. Connect to the target machine *. windbg, classic go to file -kernel debug -net. Enter the port number and debug key you used in the edit command on the target machine. For example, *windbg preview go to file -kernel debug -net. Enter the full connection string. 3. Symbol loading * after connecting, windbg will attempt to load symbols for the target machine's kernel and drivers. This process can take some time, especially the first time you connect. You'll see messages in the windbg console indicating which symbols are being loaded. Be patient and allow the process to complete. If symbols are not loading correctly, double-check your symbol path configuration. For breaking in *, windbg will typically break into the target machine's kernel as soon as the connection is established. If it doesn't, you can manually break in by pressing Ctrl+break or typing .break in the windbg command window. The target machine will freeze, and you'll have control over its execution from windbg. 4. Basic windbg commands and techniques for cntk debugging ***. Now that you're connected to the target machine, you can start exploring the kernel state and debugging your cntk related issues. 1. Basic commands ***. **help displays a list of available commands. *help command displays help for a specific command, example help lm. *g go resumes execution of the target machine. *kb display the current stack trace. *k a simplified version of kb. *p step over the current instruction. *t step into the current instruction. *bp address set a breakpoint at the specified address. Use the boolean command if you're setting a breakpoint on a symbol name that might not be loaded yet. *bc breakpoint _number, clear a breakpoint. *bl, list all breakpoints. *dd address, dump memory, dwords, starting at the specified address. *dq address, dump memory, qwords, starting at the specified address. *dt structure _type address, display the contents of a structure at the specified address. This requires symbols to be loaded to know the structure's layout. Process 00, list all processes running on the system. The first 0 specifies which process list to print, 0 is the normal process list, and the second 0 specifies to print brief information. Process _address 7, switch the debugger's context to a specific process. Replace _address with the address of the process you're interested in, obtained from process 00. The 7 flag enables advanced process information. This is essential to work within the context of your cntk application. Thread, list the threads within the current process. Thread _address, switch the debugger's context to a specific thread within the current process, obtained from thread. Thread _number s, switch the current thread. For example, 1s switches to the first thread. *reload, reload symbols. Useful if symbols were not loaded correctly initially or after loading a new driver. *sympathy, show the symbol path. Analyze V, analyze a crash dump or current system state for potential causes. 2. Finding the cntk process asterisk. A crucial step is to identify the process where your cntk code is running. Asterisk use, process 00 to list all processes. Look for the process name that corresponds to your cntk application, example the name of the executable you're running. Note the process address of the process. Asterisk use, process process underscore address 7 to switch the debugger's context to that process. This is critical because addresses and symbols will be interpreted within the context of that process's address space. 3. Investigating memory corruption asterisk. If you suspect memory corruption related to cntk, these commands can be helpful. Asterisk, address provides information about the memory region at the specified address, including its type, size, and owner. Asterisk, heap s, lists the different heaps in the current process. Asterisk, heap stat h heap underscore address, shows statistics for a specific heap. Asterisk, heap pa address, analyzes a heap allocation at the specified address to find potential corruption. Asterisk dot trap, sets a trap at the next allocation or free within a certain address range. 4. Tracing driver interactions, if applicable. If cntk uses custom drivers or interacts with device drivers, you can set breakpoints in those drivers to trace their execution. Asterisk lm, lists loaded modules, including drivers. Find the name of the driver you want to debug. Asterisk boolean driver underscore name, function underscore name, set a breakpoint in a specific function within a driver. For example, boolean my driver, my function. Asterisk use the kb command to examine the stack trace when the breakpoint is hit to understand the call chain leading to that function. 5. Debugging GPU kernel issues, if applicable. If cntk uses the GPU and you suspect issues in the GPU kernels, debugging can be more challenging. You might need to use vendor-specific debugging tools, example NVIDIA Nsight, in conjunction with windbg. Asterisk look for driver-level crashes or errors related to the GPU in the windbg output. Asterisk use, error to check for error codes. V-code example and scenario asterisk. Let's imagine a simplified scenario where cntk is causing a memory leak due to a bug in a custom allocator. While this is a contrived example, it illustrates how to use windbg to investigate. cntk code, illustrative, not real cntk code. Debugging steps asterisk. 1. Reproduce the leak asterisk. Run the compiled executable on the target machine. Observe that memory usage gradually increases as the loop in main executes. You can use Task Manager or Resource Monitor to monitor memory consumption. 2. Attach windbg asterisk. Follow the steps in sections 2 and 3 to connect windbg to the target machine. 3. Find the process asterisk. Use process 00 to find the process address of your executable. 4. Switch context asterisk. Use process process underscore address 7 to switch the debugger's context to your process. 5. Set breakpoints asterisk. Set breakpoints in the allocate and deallocate functions of the leaky allocator. Since allocate and deallocate are inline functions, the debugger may not be able to find them without further configuration like disabling optimization, compile with /od, or manually calculating offsets. Use the boolean command and the process name. Replace my executable with the name of your executable. You may need to .reload /f my executable if the symbols aren't loaded correctly. 6. Run the program asterisk. Type G in windbg to resume execution. 7. Observe breakpoints asterisk. Windbg will break each time allocate or deallocate is called. Notice that allocate is being called many times, but deallocate is never being called. This immediately points to the leak. 8. Examine memory * use commands like heap s to get a list of the heaps in the process. Then use heap stat h heap _ address to see the statistics for each heap. You'll likely see the number of allocated blocks increasing but not decreasing. 9. Inspect the stack * when allocate is hit, use the kb command to see the stack trace. This allows you to trace back to where the allocator is being called from and confirm that it is indeed being called from the std vector push _ back loop. 6. Advanced debugging techniques ****. Scripting * windbg supports scripting using JavaScript. This allows you to automate repetitive debugging tasks and create custom analysis tools. Time travel debugging, TTD is a powerful feature in windbg preview that allows you to record the execution of a program and then step backwards and forwards in time. This is extremely helpful for diagnosing complex issues that are difficult to reproduce. Extension commands * you can extend windbg with custom commands that perform specific analysis tasks. These extensions are typically written in C or C++. Symbol server configuration * ensure symbols are properly loaded by examining your symbol path. Check the event logs to see if there are any issues regarding symbol server connectivity. Driver verifier * if you suspect driver issues, enable driver verifier on the target machine. Driver verifier can detect many common driver errors and help you identify the root cause. This requires more care as it can make the system unstable. 7. Common issues and troubleshooting ***. Connection problems * double check your network settings, port number, and debug key. Ensure that the target machine's firewall is not blocking the debugging connection. Symbol loading issues * verify your symbol path and ensure that you have network access to the Microsoft symbol server. You may need to manually download symbols for specific modules if they are not available on the server. Target machine unresponsive * kernel debugging can make the target machine unresponsive. If this happens, you may need to use the Emergency Management Services (EMS) to reset the machine. BSOD, blue screen of death. If kernel debugging causes a BSOD, the mini-dump file can provide valuable information about the cause of the crash. Use windbg to analyze the mini-dump file. Windbg freezes * sometimes windbg can freeze. If this happens, try breaking into the target machine again, Ctrl+ break. If it still freezes, restart windbg. 8. cntk specific considerations ***. GPU debugging * cntk heavily utilizes GPUs. Debugging GPU-related issues often requires using specialized tools provided by the GPU vendor, example NVIDIA Nsight. WinDBG can help you identify the location where the GPU driver is crashing but usually won't give you specifics about the GPU execution. Parallelism * cntk uses multiple threads and processes to parallelize computations. Debugging parallel code can be complex. Pay attention to thread contexts and use appropriate synchronization mechanisms to avoid race conditions. The command, e.g. 1s, allows you to select the current thread for debugging. Memory management * cntk relies on efficient memory management. Pay attention to memory leaks, fragmentation, and other memory-related issues. Use the heap commands to analyze the heap. Debugging compiled models * compiled cntk models often use custom serialization and execution strategies. Understanding these strategies can aid debugging. Reverse engineering might be necessary if symbol information is unavailable. 9. Best practices ****. Start small begin by debugging a simple scenario to familiarize yourself with the tools and techniques. Isolate the issue try to isolate the specific code path that is causing the problem. Use breakpoints strategically. Don't set too many breakpoints, as this can slow down the debugging process. Take notes. Keep a record of your debugging steps, observations, and findings. Consult documentation. Refer to the windbg documentation and cntk documentation for more information. Be patient. Kernel debugging can be time-consuming and challenging. Don't get discouraged if you don't find the answer immediately. This tutorial provides a comprehensive overview of kernel debugging with windbg in the context of cntk 126/10. Remember to practice these techniques in a safe and controlled environment before applying them to critical systems. Good luck.